I'm going to talk, and I'm apologizing in advance. This is a total fire hose. This is probably like way longer than a 45-minute talk, so I'm going to talk at you very quickly, hopefully give you time to ask questions. The slides are dense, and they are online, so you don't have to take crazy notes. So let's get rolling. So, hacking and defending APIs, red and blue makes purple. The idea here is to, well, do a quick little intro. We're going to talk about why you would want to attack APIs, why that's a thing. Make this a little bigger so I can see. There we go. One more thing. There we go. Then we're going to get to the meat of the talk, which is attacking APIs. I'm going to talk both what you would do as an attacker and what you would see as a defender, hence the purple thing, and then a conclusion. So very quickly, who am I? That's actually me. I got this mass body that high off the ground and broke 2 boards. I'm very proud of that moment, although it was two years ago. Two years ago. That was when I got my EDON in Pong Pseudo Meet Quant. That was cool. But I've been doing this computer thing for a long time. I'm a Linux person. I'm talking to you and using a Linux laptop. I'm very biased towards floss and open source. I'm a Go fanboy. I've been doing OWASP for far too long. I'm on the board now, which is pretty cool, and I've done a bunch of projects. That's enough about me. Okay, so why attack APIs? Why is this even like a thing? Well, APIs are simple, right? Go to Wikipedia, right? Your program calls my program over a network, and I send some data back, right? This is simple, right? APIs are gravy. But if you think about it, APIs aren't gravy, right? APIs have a lot of moving parts. When you do this for realsies in a production environment, you have lots of things. You may have a back-ended, a application, a web app back-ended by APIs, but also have a mobile app that uses those same APIs or another set of APIs. You're probably going through a WAF or a firewall. There may be IDP in there. There's all kinds of moving pieces. You have other APIs that are in backends that are maybe in a data center, maybe in a cloud, maybe a third-party provider. Lots of moving parts. So this is one of the reasons why APIs aren't really simple, even though conceptually it's a very simple thing. For realsies, when you do it, kind of like Kubernetes. Kubernetes is easy, right? K8s, and there's only like 3,000 knobs and knobs to turn. So even if you do have a really good AppSec program, you may not have an AppSec program tailored for APIs. There's a bunch of stuff where there's crossover. SAST works for both. Threat modeling works for both. DAST might work for both, depending on your DAST tool. SCA definitely works for both. There's a whole bunch of stuff that's API specific. And if you don't have tooling or knowledge in your group about that, there's another gap. All right, so your current AppSec tool probably has some gaps. It's only partial coverage, so it's sort of like trying to catch water in your hand. You're going to catch some water, but you're not going to catch it all. All right, so your controls that you have in place are likely inadequate if you haven't really thought about this. And then there's a British mathematician, Clive Hubby, who is credited with saying data is a new oil. I think we wouldn't argue too strongly against that. And in that case, my proposition is that APIs are the pipelines that ship around that oil, right? And so this is the reason why APIs are such a thing these days, because I remember I did XML RPC. I admit it, I'm sorry. Way back when, that was early days of APIs, and they've just gotten crazier since then. Now it's sort of like if there's not an API, it's a weird thing. And then finally, browsers, right? We've had years and years of making browsers hardened and better and more controls in them and making web logins much, much better. But you don't have those same controls for an API. There is no CAPTCHA for an API. That doesn't exist, right? You can't have somebody do like the CAPTCHA thing and pick all the fire hydrants, right? And then in your Python script, right? It just doesn't work. So as an attacker, I know that there will be, almost by definition, fewer controls on an API than there would be on a web app. And I did a very interesting podcast with Neil Matatal, used to work at GitHub. Every time GitHub cranked up the controls on their login, they would literally see a spike in attacks on their API, right? Because the people who are poking at the login realized this is a pain, I'm just going to hit their API. And that happened so much that they took login out of the APIs of GitHub. That's a lot of clients that they were willing to break because they simply couldn't provide adequate protection to login. That's a huge thing. That really surprised me, honestly. When I heard him do that talk initially, I was like, you have to be on the podcast. This is crazy time. Okay, and then finally, there's different types of attacks. This is not the audience that really needs this, but for thoroughness, right, you can have a black box test where you know nothing. You can have a gray box test where you have a little bit of knowledge, white where you have a bunch, or crystal box is where you have everything, including source code. These are just different styles of sort of pen testing. And then there always is that final option, the pro bono pen testing, right? You put it on the internet, somebody will test it for you for free, right? No problem. And then I also like, when I think about APIs, I think about 3 different ways to do API security, because it's a kind of a big, muddy term, honestly. And so there, I have we'll get to that in a bit at the end. But there's 3 ways I like to think about tooling around APIs. You have API security posture. This is getting an inventory of all your APIs, understanding what you have. They're public facing, they're not public facing. What kind of data do they have? They have compliance data, whatever else. Where do the calls originate? Just understanding your estate of APIs. Then you have API runtime security. This is watching the traffic and responding to negative events or attacks against your API, right? Anomaly detection, that kind of thing. And then API security testing, and this is the more traditional DAST-like security testing. I don't honestly think of SAST as an API security tool because it's just source code. And the source code for a web app and the source code for a API really aren't treated any differently by SAST. So when I talk about API testing, I'm really talking about dynamically interacting with an API, generally. And then finally, I use a particular definition of an API, which I think is kind of important, particularly in a security context. There's really 3 things that makes up an API: a host name, a path, and a method. And the reason you need to have this level of granularity is because when you're looking at controls, changing one of those 3 values can radically change the security nature of that API. So in my bottom example, I'm doing a get to users all, presumably getting a list of all users. Okay, that might be interesting. I mean, you might not care. But a delete to that same host and path is a very different thing from a security context, right? So this is why you have to have that level of granularity. And you'll see some, I would say, tool fail where the tools can't get to this level of granularity. And that other example is a post to add an admin user to UAT, very different than a post to add an admin user to production, right? This is why you need that sort of 3 level of granularity to really get a handle on APIs. Okay, whew, we're done with the intro. And I'm doing pretty good. Okay, yay. Okay, deep breath, here we go. So I'm gonna walk through the steps of a pen test, and then for each of those steps, talk about how it would look like if you're attacking and how it would look like if you're defending. So let's start with recon and passive recon. So this is, and to my definition of passive recon is I don't send packets to the target. This is all information I get without interacting with whatever my target is. So this is kind of OSINT, right? Google Dorks, those kind of things. Looking at DNS, looking at Shodan, trying to find APIs that exist if you're doing this completely black box. You can look at GitHub issues, you can look at Stack Overflow posts, anything to get some information about whatever your target is, right? From a defender, you don't get much because I'm not sending you any packets. Like, how do you know that somebody's reading, doing Google Dorks about your company? You don't. Like, well, I don't imagine you do. I don't know how much spying Google does, but you probably don't. Like, and for some of your APIs, you may actually advertise how they work, right? You're going to tell people how to use them because that's part of your business model. So you're not exactly hiding how to interact with your APIs because that may be part of your business, right? So it gets a little interesting, right? You're going to have curl examples or postman collections or whatever to help people get familiar with your API. So you're also sort of assisting the attackers as well. Some people will put those docs behind a login if you have proprietary stuff or you don't have like public facing APIs. It kind of depends. And then those 3 facets of API security, the posture, runtime, and testing aren't really in scope here for recon. I'm not sending any packets to you. It doesn't really make sense. Okay, active recon. Now I'm sending packets to you to find out more about it. So this is, initially this traffic is harmless or just looks clumsy, right? I may be sort of sending a couple of bad logins to or bad like tokens to an API to see what happens. You might try to find clues for APIs, looking at robots.txt, watching the dev tools for API calls in a web application, like intercepting a mobile app with a proxy, try to get an idea of what's going on with the API and actually interacting with it. This is where things like Zap and other local proxies are super handy. You may do something like dirbuster or dirby or GoBuster, whatever, to do brute forcing of URLs to just try to discover them. Kite Runner is an API-focused brute forcer. That's another tool that's great. This is all just trying to get a handle on what I'm attacking. And as a defender, this is kind of like internet background radiation. I kind of joke about that, but if you put an answering port on the internet, stuff is going to be sent to it, and usually nefarious stuff. That's just life, honestly. So it's going to be a little bit tricky to distinguish this from just the normal background radiation. For SPAs, single-page applications, you may be able to notice things like the client is different than you expect. Like if I'm curling something that you should only get from a browser, you might catch that if you're really looking, although probably not. Nmap are going to happen. You'll see those if you do some brute forcing, particularly of paths that's rather noisy. That's probably something you can find easily. Posture, in this case, really just helps focus your efforts. You're going to see this a lot. Posture is honestly not a very sexy part of API security, but it's really important if you're running a program because you kind of have to understand what you have and how much love and care you want to give each of those things. And if you don't have that, it can be really tricky. Runtime can definitely discover some recon if it's noisy enough, and depending on how good that runtime tool is. And then testing is proactive. This is not really doesn't make sense for recon, basically. Active recon. Okay, this is where I'm gonna, this is for the, wait, I did that. Wow, that doubled up on me. Wow, that's messing with my head. Oh, and one thing, discovery. Wait, did I? Yeah. Discovery. This is understanding the API target. So I found a target. I know what it is. Now I want to understand what it is so I can attack it. If anybody, I've done a bunch of API testing, and usually your first chunk of time is just how the heck do I talk to this API, right? You got to figure that out. The docs are usually awful or just flat wrong. I've had to upstream proxy legitimate clients just to see how to talk to the bloody thing at times because the docs were so bad. So this can be an interesting challenge sometimes as an attacker, even after you find the API. So this is where you're learning, like I said, to talk to it legitimately, especially the authentication portion of it. How do I get a token? Is it a bearer token? Is it OpenID Connect? What is it? How do I talk to it? Looking for API documentation, the whole getting started things. Are there spec files? Open API. Anybody ever see a waddle? You've actually seen one in the wild? Oh, that's so cool. I've never seen one. I read about them. They were very academic, but the WSDLs I've seen for SOAP, God help me, I've had to test that too. But waddles are like this interesting, cool thing to do. REST documentation that just never took off, and then Swagger and now the Open API spec just killed it entirely. You may find Postman collections, right? You may have clients. I have had to do this, like I mentioned, upstream proxy a client so I could just see how to talk to that API. Same thing like intercepting a mobile app that's talking back to an API. And you may have to manually sort of gather this information, particularly if it's not documented, just by looking at, like, say, client proxy traffic. Brute forcing URLs. Kite Runner is a great one for this as well, just to get an idea of what's there. And then for Defender, right? Traffic, from your perspective, looks like there's a ham-handed person trying to learn your API, right? They're going to make a couple of manual calls incorrectly with curl until they figure it out. This, at this stage, is hopefully not aggressive enough that it looks too out of place. This may be kind of hard. And like I mentioned earlier, for SPAs, you may have you may, if you have an instrumentation, be able to tell that a client that you don't expect is calling you, but that's something that's easily circumvented by a mildly intelligent attacker who just changes their user agent, right? So that's not the best control. For undocumented APIs, you'll see a lot of failed requests. So if you do have non-public docs, that's a great sort of indicator. And here, Posture, once again, helps you define what are internal only, which if nothing else, you should never see a public IP hit. And also just how much to protect, or what of the public-facing APIs are worth protecting and by how much. Runtime, obviously, this is where you can see those discovery attempts if they're loud enough and your runtime is good enough. And then testing is also right now not really, doesn't make sense for finding discovery. And the discovery can be a time sink. I don't know if people have tested APIs in the room, but I've burned a lot of cycles just figuring out how to talk to the bloody API. So a little fair warning if you are doing this kind of testing, it can eat a lot of your time. Yay, this is the fun part of the talk. So let's talk about the active part, okay? We've figured out where the APIs are. We have a reasonable idea how to interact with them. Now we get to be naughty with them, right? This is where it gets fun. And to do that, I'm going to take the OWASP API top 10 and talk about those individually, because that was kind of the best of the list of the types of attacks for APIs that I could find. And it's an OWASP project, so why not? So go through all of these 10. So broken object level authorization, BOLA. This is a big one that happens frequently. If you look at this, this is a legitimate response, right? I have a token, a bearer token for me, and me asking for my information. So Matt's token says, please give me Matt's data, and it gives me Matt's data back. Like, this is how it should work, right? This is a normal API request. So yay, it's valid. So the next one is Matt using Matt's token to ask for Takaharu's information, right? And suddenly I'm getting Takaharu's information back with my token. This is a bad thing. This is not how an API should work. I should only be able to ask for my own information. This is broken object level authorization. There was a check to say, hey, he's got a valid token. What does he want? Instead of like, hey, he's got a valid token and he should be able to ask for this. And this is regrettably frequent in APIs. Very, very popular. I don't know if I call it popular, common thing. Popular for the attackers because it's great. Things to look for when you're looking for BOLA. Are there IDs that look interesting that you can change and play around with and get different information back? And those can be, usually are numeric IDs, but these can be also strings, like non-numeric IDs. And just make calls by and fiddle with those IDs and see what you get. You can actually just do these sort of dumb hacking tricks and be very productive. One thing you do if you have 2 user accounts, if this is a more kind of normal or a control pen test where you're hired by a company and you have multiple accounts, create something as account 1. You have an ID from that, ask for that ID as account 2. Great way to find this, right? Easy kind of test if you're manually testing anyway. And then just look around at the response types. So there are 404s versus 405s, 403s, right? They take longer to respond, length of response. All those things can kind of give you some clues if there's broken or BOLA in place. Depends. And then for detection, unfortunately, this takes some really deep inspection at runtime. I guess I do it in the next bullet point. I'll do it right now. Like, not to knock WAFs, but WAFs don't have the computational time to look at a packet close enough to say, oh, this is Matt's token, but he's asking for Takaharu's information. That's not right, right? They just have to go, looks valid, off. They don't have the time to do this. So if you are looking at runtime, you really have to have very deep inspection. And I kind of doubt you'll get this level of inspection with a WAF, although probably WAF vendors will throw rocks at me or whatever. But I just don't see how you have the computational time to do that. And it's shaped like a legitimate request, right? It's JSON, perfectly structured. It has valid IDs in it. I'm just asking for the wrong thing. But otherwise, all the strings and bits are perfect. So it looks like a normal request. If somebody is looking for BOLA in your API, you're probably going to see a lot of authorization errors. So that may be a clue that you have somebody investigating if there's BOLA in place. So that is one way to sort of the attacker to tip their hats. Or if you have really good inspection, you may be able to see 2 different requests from the same client in a short period of time. That could be an indicator, but it could also be 2 people behind a proxy. So it's not a great indicator, but it may get you something. And then once again, for posture, yes, this is where you focus on the most risky apps. Runtime, if you have deep enough inspection, can detect BOLA attacks. And then testing, hopefully your testing tool or framework or whatever you have, your tool, has the ability to find BOLA and do those kind of play around with authorization requests. Depends if you have an API-specific tool, really. Okay. Broken user authentication. So this is the case where I can, air quotes, log into an API, right? You send me a username and password, I give you back a token, and you make the rest of the request with that bearer token or some such thing like that. Obviously, I can brute force credentials. There's no reCAPTCHA, like I said, in APIs, so I can usually brute force those a bunch. And if they don't have good monitoring, like, APIs are made to respond fast. They actually kind of help your brute forcing. They're designed to be fast. So it's kind of a nice thing for an attacker. You can do password spraying. You can look for goofy things like base64 protections. I've seen that before. It's a bit sad. You can do all kinds of mistakes with JWT tokens. allowing, not properly checking the algorithms, having weak secrets, or like the none algorithm. Like we didn't learn that with TLS or SSL back in the day. Let's have a none algorithm that's going to be fine. No one will use it, etc. So there's a whole bunch of things you can do on the and there's tools just to do this kind of JWT breaking, like JWT underscore tool is one of those examples. On the defender side, right? Luckily, brute force attacks are noisy. So if you have reasonably good runtime protection, you should be able to see this. Tons and tons of requests that fail ought to stand out pretty blatantly. Password spraying, also very noisy. You need to make sure the crypto, this is more of a configuration thing, but the crypto is good on whatever token you're using, particularly JWTs. There's a fantastic reference. If you Google JWT best practices RFC, it really walks you through what you need to do with JWTs. JWTs are a whole interesting like sideline topic. It's a good spec if you pick the right options. They just gave you some really bad options along with the good ones, unfortunately. And GitHub removed off altogether from the API. And honestly, if I was writing a greenfield API, I'd have them go to a website and get a token through that. You have way more better controls to understand that Matt is in Dublin today asking for a token, and I can't in an hour ask for a token back in Texas where I live because there's no planes that fast, if nothing else. Right? Those controls exist for web apps. They don't exist for APIs. Okay. Whew. Excessive data exposure. So this is an interesting one. So developers want to be productive, and they like cheats. I develop software. I like things that make my life easier. And one of the things that can happen when I make my life easier as a developer is I can say, take this object and in one method called JSONify it and ship it over the wire, right? That's nice. I make a database call, I get some data, I JSONify it, ship it over the wire, a couple of lines, Bob's your uncle, I'm done, right? Great. Except for if all of the data in that SQL response is not supposed to go across the wire and you're relying on clients to silently ignore that bonus data, you're in a bad place. Right? Because if it's a mobile app, yes, it'll probably ignore it if it's your mobile app. But I don't have to use your mobile app. I just have to use something that talks HTTP. And so for an attacker, I look for these responses that provide bonus-free additional information because he uses this automatic JSONifying method of whatever language you're using, and suddenly I have all this extra data that I can play with. This is really common in SPAs and mobile apps. And to be fair to developers, you don't know with the REST API, that client or the contract between you and the client is somewhat fixed. It is very fixed. And so you may put in extra data, assuming, they're going to ask us about that in a week. I'm just going to give it to them, the response, and then they'll say, hey, it's already there. I'm done with you, right? So I see why this happens. And doing it right can be painful. But as an attacker, I'm going to look for things that have extra information, interesting pages, profile pages, like internal metadata that shows up in a thing that's not anywhere in the UI. Those kind of things are hints that there may be excessive data exposure. And then as a defender, this is really hard. You made the request look like that on purpose. So when I'm as an attacker finding excessive data exposure, I get a normal response. It just has way more freaking data in it than it should. So unfortunately, like runtime has a hard time seeing this. Now, one way you might be able to see it is I found this exposure and it's a per, say, client or customer exposure. Then I might make multiple requests to scrape all of your customer data. That gets noisy. But the initial request is just a request. How do you tell it apart? And honestly, SAST is probably better here. You want to look for whatever your programming language to JSON is, which most of them have. I mean, if you have that, that may be a function you might want to consider banning or otherwise having some conversations. The real way to fix this, honestly, is outside of a normal Defender's world. It's really a dev thing. You have separate data objects for internal data and what you ship over the wire. And then as a developer, I have to manually write, this is annoying and tedious, but I have to manually write code that pulls out of my normal data object and sends it to me, adds it to my API data object, and then ships it. Because then every piece of data that goes over the wire is very explicit, right? Not exciting and sexy from a programmer perspective, but it definitely gives you a much more rugged API. Posture, once again, this will show you things that have the chance maybe of having larger responses rather. Runtime, like I said, can detect scraping because now I'm doing this en masse, but it's certainly not going to see onesie twosies of this. And if I'm low and slow, I'll probably be blind to you, fortunately. And then testing, like looking for verbose responses if you're interacting dynamically is the way you'd find this. Whew, okay. Where am I at? Well, I'm doing pretty good. Yay. Lack of data and resource limiting. Okay, so this is, I'm not doing any kind of resource like CPU, RAM, or rate limiting, right? Where you see this as an attacker, I found this a bunch of times, so you can have fun, is pagination, right? If the pagination is not well designed or not there at all, you can have all kinds of fun. So I have I don't know, like my pets. I have a site that lets me add my pets. Well, let me add 10,000 pet names, right? I can get a list of 10,000 names. I can add 10,000 pets potentially. And then why don't I ask for a list of pets? I doubt they ever tested somebody with 10,000 pets, right? This is a great way to find these little corner cases where things blow up from an API perspective. You can definitely get API denial of use, I guess you could call it, or denial of service. If I do pull that request and it eats up all the RAM and CPU getting the 10,000 pets for me, that could be fun. Fuzzing and brute forcing can sometimes find this. You can modify requests to look to see if you can get past rate limiting by fiddling with the headers, like X originates from, or those other kind of X IP client, X originating IP, those kind of things. If I'm making decisions based on that header and I can inject it, I can sort of bypass those injections. One thing with fuzzing, if you can look at the longer time, the requests that have a longer response time, that's a great clue that this is maybe DOSable, if that's in scope, if you're testing nicely. And you just play games with case and other things to try to bypass any rate limiting you find. Sometimes you can, sometimes you can't. Null terminators, those kind of things. And then the other thing you can have, honestly, is rates too high. If you've never really performance tested your API and you have a rate limit at 15,000 requests per second, but it falls over at 10, that 15,000 rate limit is ineffectual, right? It doesn't matter. It's dead before the rate limit kicks in. So you can actually have rate limits that just don't help you. Okay, from a defender, these requests are going to look normal, mostly, but with larger responses, right? If I'm trying to understand, or if I'm trying to particularly resource consume you as an attacker, I'm going to look for those that use a lot of resources. So if you have good monitoring, observability, whatever you want to call it, right, you can at least see these spikes and get a clue if you're really watching the store that close. Look for weird requests that have odd headers added, because a lot of times I have to guess, which of these potential headers, like client IP, requester IP, remote IP, am I using? Well, I don't know. So I'm going to guess a couple of them. You can see these unexpected headers. That's a little bit of a tip that you might be getting attacked. And many methods are going to try to stand out because I'm doing these weird null terminators or adding headers or funky things where it just doesn't look like normal traffic. So if you have good runtime analysis, this will stand out as aberrant traffic. Once again, posture is really helps you determine what APIs need that rate limiting. Runtime, if it's good enough and can see those differences, you can find those runtime exceptions. And then fuzzing is really probably the best way to find these, if not just configuration management kind of things. Because a lot of those rate limits aren't necessarily enforced at the API; they're enforced at an API gateway or some other piece of infrastructure that's upstream of the APIs. Come on, you. There we go. Okay, broken function level authorization. This is where I have a group or a role where I can ask for things that don't belong to my group or role. The obvious example is I'm a normal user and I make a request to an admin function, right? That's the trivial example. So these really only applies to APIs that have multiple roles. So yay, if you have a single role API, you might be lucky. This is not an issue for you, right? If you do have a multi-role API, then this can be an issue. And these are things like using a normal user token to call an admin API. If you're not being smart about it and the same code base is doing both of those request handling, I may be able to use a normal user thing to an admin API or a backend API or whatever you want to call it. Other things that are fun to try, undocumented methods. Yes, I know the doc says this only accepts Git, but I'm going to send a post and see what happens. Why not, right? Or a put or a delete or a whatever. Like, I've had great success just guessing methods that weren't documented, and they just work. A lot of the frameworks automatically wire all this stuff for you. You may not be purposefully allowing a post, but if the framework did it for you, it may be there. If you want to find this, create groups, create items with, if you have two roles as a tester, create items with one group, request those items with the other group. Obviously, that's just like with the old example, a great way to find those things. You can brute force this sometimes and get lucky. And you can also play around with headers sometimes and get lucky. Those are usually kind of the tail end of your Hail Mary attempts to get somewhere. And as a defender, right? Obviously, if you have an API with two or more roles, this is in play, right? If you have one role, maybe wipe your brow and move on, you're good. Calls for unsupported methods. If you know you're never supposed to get a post to a method and you start seeing posts to a bunch of methods, that's a clue that someone is not either reading your docs or playing nefariously with you, right? It's an indication that something odd is going on. If you have decent runtime, it should find that. Same client, different roles within a short period of time. Another good indicator, not necessarily a terrible indicator, but it might be a clue to keep an eye on something. And a bunch of unsuccessful requests, right? As I'm trying to find out what I can and can't get, I'm going to fail a lot as an attacker and make some amount of noise. So if you're at least keeping an eye on those failures, you can catch this stuff. Posture will help you determine what APIs are in scope for this that have multiple roles and then how much care and feeding to give them. Runtime I need a drink almost. Runtime can detect this, particularly for larger requests or oddball requests that make this happen. And then testing, obviously you want to conduct authorization testing early, if possible. Come on, there we go. Mass assignment. So we talked about excessive data exposure being, I'm giving you too much data. Mass assignment is the opposite side of that. I'm accepting too much data. I have the from JSON to database call, and I take in whatever JSON you give me, and I ship it to the database. That's the underlying problem here. So as I am looking at an API and interacting with it, look for requests that look like they're missing or they have partial data, right? What can I add to that to find out more, right? Look for requests or responses where there's differences. This is another great indicator. And you can guess. The nice thing with this as an attacker is I can just add arbitrary fields to JSON and ship them in, and 99% of APIs will just ignore them. So it is noisy, mind you, but it doesn't break things. So I can just add 10 or 15 fields to the end of a JSON body and ship it off and see what happens. So if you're finding this doesn't have to be hundreds and hundreds of requests, you can sort of bulk up adding a bunch of things. Like I think this may be the 4 different ways they might add an admin user. I'm going to just tack them all onto the JSON and see what happens. Because usually if they're not mapped, they just silently ignored. Sometimes you will get error messages that will give you hints about required fields, which is pretty handy. Fuzzing can sometimes find this. And if you combine this with BOLA, you get really exciting times, right? If I have BOLA, where I can make requests as other users, and I have mass assignment that I can make another user an admin, right? Or have all kinds of fun and games with this. So if you can like tie this up with other API issues, this one gets super fun as an attacker. Yeah, I got some water. Oh, you're lovely. That was needed. Thank you. That's awesome. Man, I asked for water and it just showed up. I would like a Porsche. Oh, crap. I tried. Okay. As a defender, right? Request stands up from the normal because there is additional fields. So if you have reasonably good runtime protection, they will see that, wait a minute, this thing should only have 12 elements. There's 13. This is weird, right? So you have a decent chance of catching that with runtime. The request size will increase. And if you have different roles, this gets even more scary. So if you have multiple roles, you really want to make sure you don't have mass assignment issues because you can do that fun add admin to a bunch of users thing. Posture will give you an idea of which APIs to focus with. Runtime is really what will find this. And testing obviously should cover this idea of mass assignments. And hey, if you're doing the testing particularly manually internally, you know what those fields are that are also in the database that shouldn't be in the API. Just add those to your tests. And they should hopefully fail, either noiselessly or with some kind of error message, and you know you're good. You won't get regressions over time. Okay, there we go. Security misconfiguration, we're close. This is the basics. This is like I don't do TLS right, I have default passwords, those kind of things. This is not the most exciting, honestly, of the API top 10, but it's also very critical because you can shoot yourself in the foot very easily by messing up security configurations. Like all the awesome coding doesn't matter if it's set up in a poorly configured, say, cloud environment. As a defender, this is the basic vulnerability scanner stuff that you can find. Passive monitoring of traffic can find a lot of these misconfigurations, like if you have weak JWT tokens or those kind of things, or headers, or those kind of the API gateway bypasses, right? Runtime can see that if a public IP hits what should be an internal-only API, that's a clue. Speeding up a bit because I'm kind of tight on time. Injection. This is our normal injection, right? Where I'm treating data like code and fun things happen. Look for places that you know are interesting pieces of data. Tokens, API things, header, query data, right? Anything in the body, obviously, is subject for injection, right? Any kind of data that's being processed. Recon may help you sort of focus on the most important things. Error messages can also help, although most APIs don't actually give you error messages, unfortunately. And then injections, right? You can look at fuzzing lists. The OWASP testing guide has loads of these listed there. Second order injections, a little short side. I worked at Rackspace in the product. I ran the product security group for Rackspace for a while. Just so happened that one of my people was testing an API while another person was testing this web backend interface thing. And person 2 gets an alert window with a random string that he didn't put in anywhere. And he's kind of having a, oh, shoot moment, thinking that we got popped or something. Well, it turns out that the person was fuzzing the API, and that string went through 6 systems before it popped up in the web UI. I got written to a worker, the worker pulled it off a database, handed it to another worker, bing, bing, bing. 6 different systems handled that before it popped up in the web UI. Crazy second order attacks. They're fun. We just got dumb luck, honestly, that 2 people happen to be testing those 2 things at the same time. Or else, honestly, we never would have found that, I don't think. Obviously, input, validation, output encoding, standard stuff here. This is nothing really new. I'm surprised at how many times I can do things like, I was an API, I was sending a script alert script tag, the traditional XSS 101 thing, as a phone number. Like, why is it accepting a script tag as a phone number? I can't type script tag on my phone. This will be this will make a lot of noise. If I'm doing injection testing, it's going to be noisy. I'm going to try a bunch of things if I don't know much about your backend. So this will hopefully be found by runtime. And then the other thing that's interesting is east-west. There's this idea of API north-south is sort of from public internet to your APIs. East-west is sort of intra-API traffic. East-west traffic is generally highly trusted. And it probably shouldn't be. Like, why would the guy who works the next cube over attack my thing? I'm just going to accept all the data, right? Ugh, scary. So east-west are really interesting for injection attacks. And then proper asset management. This is basically, do you understand and have an asset management like Tanya talked about in the keynote? Do you have a list of all your stuff? From an attacker, you really won't know this at all. This usually shows up as a highly productive pen test, right? I have lots of findings because I have no clue what they have. And I have a good time as an attacker. Maybe the people who hired you won't, but hey, that's just life. And then for a defender, you need this. You really, really need this. It's critical. Tanya said it's the first thing she does. It's the same thing I do. I've worked at very few places that actually had that, but I always work to get that done. And really, too, east-west traffic and those kind of things is very good to know. What's public, what shouldn't be public. Like, you can't write a rule in a runtime environment if you don't know that that API should never have public traffic, right? You got to know these things to write the controls to make them happen. Okay, insufficient logging and monitoring. As an attacker, again, this is one that you sort of have to infer because I can send loads of trash to something forever and I never get blocked. Like a lot of times as I'm getting towards the end of my pen testing time, I just get noisier and noisier with my attacks because I'm half curious if they're even going to notice, right? So this is if that happens and you never have any kind of feedback, that's kind of a clue. They're probably not monitoring logging very much. But you really can't tell as an attacker, unfortunately, because that's sort of on the other side of the fence, particularly if it's like a controlled pen test thing. And defenders, like, we're never attacked, right? That's a good way to know you don't have sufficient logging, because guess what? If you're on the internet, you're probably attacked, at least internet background radiation. Another clue, you have a hard time diagnosing API issues. Like suddenly you get CPU spikes, you have no idea why. Well, you might want more monitoring and logging. Like, go figure, those kind of things happen. And in this case, the monitoring logging is really runtime. Okay, woo, we made it, we're close. 5 minutes, I'm perfect, thank you. So here's a couple bonus things I didn't fit into the top 10 that I thought were worth talking about. Fuzzing in general, right? As an attacker, this is a very useful technique, actually. I found all kinds of things fuzzing. This is where you play with different values, different negative numbers, large decimals, integer for decimal. You gotta love those like non-strongly typed languages that'll coerce things into data types for you, like Go Team. Makes it fun as an attacker. There's loads and loads of list of tag strings to get online. You don't have to like struggle for this. You shouldn't. And then looking at response code, response times, timings, error messages can all give you kind of clues for issues when you're fuzzing anything really, but APIs. Obviously, as a defender, lots of requests from a single IP over a short period of time is a clue you're being fuzzed, right? This should stand out very blatantly. It's going to be very noisy. You're going to see spikes in RAM or CPU usage or just number of requests per second. So this should be a fairly easy thing to find as a defender. The other thing I like to talk about is structural versus data attacks. And this was kind of a thing that took me a while to figure out when I started poking on APIs, but it's a really good distinction to make. So I'm going to start with data attacks. Data attack is, right, you have a data structure, a JSON, let's say, that has data in the field names and the value types, right? And the values. I can inject stuff into those. I can play around with those, but I don't change the structure of the JSON data. Structural attacks are, I just do crazy crap with the structure of the JSON or the XML or whatever the data whatever that API wants. And these are super productive, right? If you're attacking a thing and it expects only one sort of child element in a JSON structure, send 7, see what happens. Sometimes fun things happen, like the thing falls over. I had one, like the most dumb attack ever. I injected 32 meg of space in between 2 XML tags and took on an API with a single request. Like, that is the world's most stupid HTTP ever, but it's valid, and it took out the API. So structural attacks are really fun. Like, I like those. The other thing that's interesting about structural attacks is most QA kind of tools or clients only make properly structured attacks. So this is something that is generally not well tested, right? So this is a highly productive area if you just do crazy crap with the structure, to be blunt, of what you're sending to the API, crazy things will happen. Whew, and then special notes on GraphQL, because I haven't really talked about GraphQL at all. Recon discovery, brute forcing APIs, all that stuff is kind of the same. Local proxy are obviously very useful for that. There's GraphQL plugins for the local proxies. Usually there's documentation getting started to help you sort of poke those if you're an attacker. Different for GraphQL, there's this wonderful thing called the introspection that allows you to learn the schema of the API. And a lot of APIs, GraphQL APIs on the public internet will give you that. And suddenly you have the schema of all of the data of the API. Super useful as an attacker. GraphQL is like a query language, right? It's like SQL over HTTP almost. And the great thing of it from a developer perspective is I don't have to guess at what the client wants. They can just ask for it. It's like a database call. As long as there's table data there, they can get it. So there's not this weird forced connection between the version of the REST API and the client. And I want to add something on the client. I got to rev the version of the API. All that goes away. So this is only going to get more frequent. It's a really useful pattern from a developer. It's just interesting to secure right now. That's all I'm going to say about GraphQL. It's left to you as an exercise. Conclusion. So key takeaways for API testers. All an API really is a web app without a UI. That's all it is, right? When you test web apps manually anyway, you're looking at HTTP as it is. Guess what? You're looking at HTTP stuff when you're testing APIs. So if you know how to test a web app, you have a pretty good start on testing APIs, right? So maybe there's just a little bit of delta. You can use the OWASP testing guide to get a pretty good foundation if you're completely new to this. There's a couple of special knowledge you need on APIs. I'll talk about that in a next slide. And then gaps. Because of all the gaps that I enumerated earlier, this is going to be a highly productive area of testing for years, I can imagine. It has been for me. When was the first time I tested an API? But it was 2010 or so was the first time I got hired to test APIs, and it's only gotten more. So this is like a great area to understand stuff about or learn more. So I created this web page. It's API security tools under the community section of the OWASP website. I actually did a merge request yesterday for a new tool, so they're constantly being added. This is me and a whole bunch of people who've either sent me emails or did PRs directly into this thing. So if you want a list of tools, they're all there. They're divided into what their licensing is, if they're posture, runtime, or testing, or all three, or whatever they are. So it's just a great resource to just get a good list of API tools. And if you find them, do a PR or send me information. I'll gladly add them. Not a problem. And then for defenders, I did a chart basically where posture, runtime, and testing are either strong or weak. You kind of need all three. If you look at this next slide, there's a couple areas, though. Obviously, mass assignment, posture is really not going to help you much. And for improper access management, guess what? That's what posture is. So you kind of have to have posture. Insufficient logging and monitoring is kind of runtime. So that's obviously a strong tool. Woo! I apologize. I gave you a fire hose, but I think I landed on time. And thanks. And then questions if you have them.
Now, thank you, Matt, for your presentation. This is really good.
And the deck is available here on slide share. I put all my decks there. So,
guys, someone have some question for our speaker. Please take it in. Please, go ahead.
It seems like general, in my impression of this general summary is that realistically, the defender side really are extremely limited or have to do a lot against work basically. And a lot of this won't really work unless you're actively alongside red team.
yes, I would agree with both those statements. The real key thing is whatever. If you noticed, you saw the trend. Runtime is really important for this as a defender, right? Posture will help you make allocation of resource decisions, but won't really protect anything, right? And so it's really runtime and testing. Obviously, if you can catch it early, great. But for stuff that's out in the field, it's runtime. And so the key thing is to have a runtime thing, tool, whatever, that understands APIs, right? And I think it almost has to be, just to be blunt, not in line, because I don't have computational space to do as much thinking as I need to do to deeply inspect API traffic in a WAF or something that's in line. Just that, I think that's just the reality. Now, yes, that means that attack one may make it through before your runtime figures out attack one happened, but at least you're going to block attack two, right? Is probably the best you can do. That's a great observation.
Yeah. We have another one question. Please go ahead.
Oh, well, it depends if you have either of those or none of those. I would generally set them on an API gateway just because those are made for APIs. They're usually smarter about how they work with APIs. But most of the WAF vendors now, if nothing else, are putting bullet points on their websites about API security. So you might get lucky if your WAF is good. I haven't evaluated WAFs for API security at all, so I don't have a recommendation. But I would generally, if I had a gateway, I would do that there because that's what they were kind of made for.
Please go ahead. Yeah.
Sorry, you had the recommendation there, like do throttling basically, right? Which then makes the other recommendation is detect fuzzing, which is problematic. So how do you do fuzzing detection if you're also throttling?
No, that's a great question. You could throttle so much that the fuzzing detection.
Yeah.
So that's a trade-off, right? Are you willing to trade off not being able to detect attacks but block them, which is what the throttling might get you, or at least stymie an attacker who's trying to fuzz you? I had one. This is a web app that the same idea applies. I had one web app that I tested. What was the only positive pen test finding I've ever written, and I thanked them for this because they actually made my life suck as a pen tester. They had a incrementing time on logout, on password attempts to log in. And so you couldn't really functionally fuzz it. I left a fuzzer running from Friday to Monday, and I didn't fuzz anything because they just kept increasing the time. And I tried playing IP games. They were really smart. However the hell they implemented it, I didn't ever get to see the code, but they were really smart about it. I'd rather not know of an attack that I could block because obviously blocking is the ultimate. So I'd almost rather have more aggressive throttling to make fuzzing less functional than to worry about being able to see it. It's almost kind of like, I don't know, do you want to see somebody attacking you or just have them not attack you? Well, I'd just rather have them not attack me. Yeah, sure.
I have one. In my experience, you have a very strong red teams, and you in another side, you have a really strong blue team that sometimes they don't speak to you. So this is the real problem in API because especially when you're using, for example, also information, only the red team knows, but the blue team never knows because it's not noise about it. And how, in your experience, how you manage this in the purple team? It is really important to be a purple team.
Yeah, I would want to do with red and blue teams almost what DevOps does with Dev and Ops. You should have people have at least some empathy or understanding of what the other side of the fence is. So if you can have this luxury, rotate red to blue and blue to red for a day, a week, an hour, or whatever, just to see what life is like. Because I could easily see a red or a blue team member going, why are you doing that? No, what you just do is this. And then go, oh, wait, what is that? And boom, like you suddenly have learning, right? That kind of interaction of the teams, I think really helps drive empathy and have people understand. Because you're right, if you've only ever done red team, that's what you know. What do you know about blue, right? But if you've done blue, you may not have never seen red. So having that intermingling of those two groups is really key to get that kind of cross knowledge.
Nice, thank you very much. I don't know if anyone have another question. Please go ahead.
Yeah.
If you have a large organization with several pods, you do the random teaming like centralized or maybe like the rest and the ops teams?
Oh, interesting. Ooh, that's super interesting. I would almost base that less on technical and more on political. Like, do those teams play nice together? Well, then it sort of doesn't matter. Or is there like different managers above that will get their pride hurt if one makes the other look bad? You know what I'm saying? Like, I've had tons of completely non-technical things that changed my decision. Like, perfect example, unrelated to API. I did a training one time, and I said, here's one way you can do this thing to do triage issues coming into a security assessment program. And I suggested a couple tools, and I had one of the students come up afterwards and say, yeah, we have ServiceNow. Can we use that? And I'm like, well, sure, it's a ticketing system, but the more important thing is, can you get a queue created easily? Can you work with the ServiceNow team and get this done? Or is this like a 6-month thing to get a change? So really, it's not less the tool and more how functional you can be with that group. Does that make sense? Yeah, because a lot of those really, I don't know that there's a big technical difference. It's more of like, what can I get done? To a lot of what Tanya said in the keynote, honestly.
Okay, thank you so much. We have lunch and anything, but if we have another question, no. Just an announcement. Just remember myself. We have an upgrade in iPhone if anyone is using iPhone because they take a look in API problem.
Okay.
And solve this because API, remember?
Yeah.
And maybe it's a very good thing to go up today.
Update your iPhone? Yeah, do it. Keep your iPhone updated, obviously. Yep. Thank you very much.